In this section, we're going to talk about the second derivative. And not only what it measures, what the second derivative, what information do we get about the graph, but we're also going to go back and forth about when there are meaning behind these variables, what does the second derivative information give us? So one thing to remember, we have derivatives in general are rates of change. So f prime is of x. This is the rate of change of y equals f of x. So we talked about in practice before about when this is positive, what does that tell you? When this is negative, what does that tell you? And various things like this. But this is a function in of itself in a lot of instances. For example, when so this is before, and when we are looking at y equals f of x, when this is some sort of position, height, distance at a certain time, if that's a function, you put in your time, I'm not writing that down, and you get out the height of the ball after you throw it. We talked about that f prime of x gives us our velocity, which technically is instantaneous velocity. And in a lot of situations, not only is the velocity important, but also how is the velocity changing? For example, if they're investigating accidents, they are going to want to know not only was the car or truck speeding, but were they accelerating or decelerating? Was it that intentional that they sped up to, crash into the Starbucks or whatever? Or did they try, did they try to brake? Or even worse, not even worse, but on a different note, there could have been a problem with the car. We've had recalls because people thought that they were braking, but they were able to see that the car, from investigating the accident, that the car was actually speeding up because there was a flaw in the design. There was some flaw in the braking and gas mechanism of the car. So not only is the velocity important, but also how it's changing going to be important. And so we want, how is velocity changing? In other words, what is the rate of change of the velocity? We want to be looking at the derivative of velocity. And some of you may know this from other classes. How velocity is changing is measured by acceleration. And so that's a concrete example from physics, but also we're going to talk about in other situations also this type of situation of looking at the derivative of the derivative is going to be important. So this acceleration is the derivative of the derivative of f of x. That's what acceleration is. So you can say that acceleration is the derivative of our velocity, or what we're going to learn right now is this is the second derivative of our original function position. So we have y equals f of x. In this case, we have the second derivative of f of x is the derivative of f prime of x. So the second derivative is the derivative of f prime. And it's denoted by, I already used the notation up here, F double prime. So that's how you verbalize that notation. We already talked about this is F prime of X. This is F double prime. That is the second derivative. Leibniz notation is pretty messy looking, but I'll write it so we can see it and recognize it. We have the first derivative. In Leibniz notation, would be df dx, or sometimes dy dx. Again, this can be useful because it tells you what the variable you're using, and it also reminds you what the units are, which we'll talk about in a second. The second derivative is even messier looking. And you have twos in two different spots to signify the second derivative. And I always had a hard time remembering where the twos go. If it's written for you, that you don't necessarily need to remember because it's already there. But if you were to be forced to write it in Leibniz notation, one way to remember is you're starting with df dx, and then you're taking the derivative again with respect to x. And because of that, this becomes d squared f, and technically you might think about it as dx squared, but that looks crazy. So they make it a little bit better by not having the parentheses. So that is one way to remember Leibniz notation for the second derivative. Another thing that we want to think about is, what are the units on f double prime of x? And thinking about it as we're taking the derivative of the derivative, there are different ways to express it. You would have units of y per units of x squared, or you might have units of y per units of x per unit of x. And that is weird, but in the case of acceleration and velocity, we might think of it and remind ourselves, and we may realize we've seen this before. If we're thinking of this in meters at t seconds, then our velocity would be in meters per second. Notice how we write it as a fraction, but we a lot of times verbalize it as meters per second. Acceleration would be, some people write it as meters per second squared, or you might see it as meters per second per second. And so in the next several videos and problems, we'll practice what is the meaning of the second derivative.